to the function, draw over and down. Map that up to the function, draw over and down. And same thing with this one. Wow, it's way too skinny. And the last one, over and down. In a left endpoint scheme, you always use A and never use B. In a right endpoint scheme, you always use B and never use A, right? In terms of the rectangular height computation. Obviously, A is always in the formula. But you see, the 2 itself is not being used directly. All right, so there's our illustrated Riemann sum. Those rectangles we want to compute. Calculate. So we're going from I equals 1 to 4. 4. Function. The rule is A plus I delta x. We have those things figured out in delta x. So that's the most arbitrary. Okay, so now we'll fill all the pieces. 1 to 4. F of A is 2. So 2 plus I. Delta x is a half. So 1/2 I. Times delta x, which is also half again. Replace function. Function x squared minus 1. So you got to plug this expression, this is going to go more cumbersome, in for x squared and the x squared minus 1. So we'll have the same summation symbols, n equals 1. F is x squared minus 1, so we have 2 plus 1/2 I quantity squared minus 1. That is the function, times the 1/2 on the outside. In all these problems, where you have a finite number of rectangles, n is a finite value, everything in this section, not the next section, then this delta x always comes, you can always bring it to the outside of the summation, right? You always get that constant delta x right there. So that's a constant multiple. You can take it to the outside. You don't have to multiply it in, right? Now we'll have, expand out this square. So 1/2 sum I equals 1 to 4. All right. So we'll have 2 squared. It's 4. We'll have a 1/2 I squared, which is a 1/4 I squared. Right? And we'll have a duplicated middle term of 2 times a 1/2 I. We're going to double that, right? Square binomial, right? Square the first, square the last, double the product, right? So 2 times a 1/2 I is I. We're going to double it because there's a double middle. So what do we get? I don't know what I just said. 2 plus 2 plus 2I. And then minus the 1 still sitting there. Okay with that? All I do is square it again. Bigger?
Like, how did you add 2 to the 1/2 I?
So when you square this, right? So it's 2 plus 1/2 I. 2 plus 1/2 I. So you get 4. You get a 1/4 I squared on the end. And the middle is going to be 2 times a 1/2 I plus 2 times a 1/2 I. So I have 2 of those. So that's an I and another I. You always have a doubled, we square binomial, you always have a double middle.
I know that, but like,
that's where the 2 came from, 2 I's.
I know, but like, that has an I on it.
Say what?
Can you cancel out the 4 with the -1? Just get 3 plus 1.
Hold on, I'm not understanding Barry's question. Hold on 1 second. Say it again.
It's like you added 2 and something with the
I'm multiplying. 2 times a 1/2 I.
Okay.
Yeah. All right. Roger, what were you saying?
Yeah, can't we just take the -1 out and just put 3 plus?
Yeah, I'll make that 3. All right. So now we have more concisely. We make the 4 minus 1 a 3. 3. I'm going to write it though as a polynomial in I. So I'm going to put the 3 last. So I'll write it as 1/4. This is a good practice you should do for the next section. 1/4 I squared plus 2I plus 3. I goes from 1 to
Plus
4.
3.
4 minus 1.
Okay.
And I wrote it descending over powers. I wrote it like a polynomial in I. Yeah.
I have a question. So, what if, like, you know how you pulled out the 1/2 in front of the summation?
Right.
Could you, instead of pulling it out of the, could you just like plug it back into the equation?
Maybe multiply it through here
Yeah.
right now.
Yeah, I'm just saying.
If you want to, yeah.
Because I'm like, that's what I.
You can't do it. You can do it in here,
Mhm.
but the 1/2 only goes on the outside of it. You can't put the 1/2 in on this and this because it has a square on it.
No, I'm saying like once
Over
you
here?
like, yeah.
Yeah, certainly. Yeah, if you want to.
Okay.
It's up to you. All right. So now we're going to take this over here and finish it off. So you see now why I introduced the formula we had a minute ago, right? For these summations. This is the sum of squares, the sum of I, and then a constant, right? So it's got all three of them. We didn't have the cubic one.
Can you separate it on?
Yes, correct. So we'll have 1/2 on the outside of the whole thing, unless you're zealous, and you're going to put that in there. It's up to you. 4 of 1/4 I squared. The 1/4 can go out the side of this, 4I squared, right? 1/2 on the outside of the whole thing. With the 1/4, once you push this summation notation on each of these three pieces, then much like the antiderivative symbol, much like a derivative symbol, right? You can take the 1/4, you take the constant multiple to the outside of this individual notation. So 1/4 comes to the outside of the first one. You just have the I squared, which is the formula you're looking for, plus 2 sum I goes from 1 to 4, plus 3 sum 1, going from 1 to 4. This way. Okay. Any questions about the move from the far right to the far left? Just distributing the summation symbol is all we're doing. Distributing the summation symbol. Applying it only to the parts that vary with I, right? I squared, I, and this has a constant here now. All multiplicative constants go to the outside. It's like limits, right? Anything that's not changing with limit and it's multiplicative, put it the outside, right? 1/2 times 1/4 on the inside. What is the sum of I squared from 1 to 4? We use the formula is probably more cumbersome in this case, actually.
Wait, so are we using left hand?
We're using right. We're only doing right.
Okay, we're only
In
doing
this
right.
problem, we're only doing right. We started the formula for the right. Going from 1 to n instead of 0 to n minus 1. Adding up the first 4 squares is not a big deal. So I don't know if the formula is that necessary. What's 1 plus 4 plus 9 plus 16? 30? Okay. It's not that hard, right? So 30. Better than trying to construct that formula in here for no apparent reason. What's the sum of from 1 to 4? Bowling. 10 again, right? So plus 2 times 10. What's the sum of 1 added to itself 4 times? 4. So you could if you were zealous. Just want to make it clear or something, right? Know where the things are coming from. So he's going to have to say where that comes from, right?